Hello students, welcome to all of you. And in this previous lectures we are just start to discuss the new topic, that is magnetism. In the previous lectures we are discuss what are the magnets and some properties of the magnets and some introduction part about the magnetism topics. In these lectures we are discuss the magnetic line of forces and magnetic field. In the topic of electrostatic we are discuss the electric lines of forces and electric field. As like same we are start to discuss the magnetic lines of forces and magnetic field. Magnetic lines of forces and magnetic field. Then as like the electric field, electric lines of forces, they are start from the negative start from the one for negative charges to the positive charges, negative pole to the positive pole. The magnetic lines of forces are originate from the north pole. I will be drawn one of the diagram to here. This is the bar magnet, okay, and this is a north pole and this is the south pole. This is north pole and this is south pole. The magnetic lines of forces are originate from the north pole and terminate or end to the south poles. But I'll be drawn here to intersect of two different lines of forces, but they do not be intersect. I will be tell in the properties when we are discuss the properties of the magnetic lines of forces. The magnetic lines of forces are start or originate from north pole and end to the south pole. They are start from the north pole and end to the south pole. Let's start to discuss the properties about the magnetic lines of forces. Properties of magnetic lines of forces. The first property of the magnetic lines of forces, when we are start to discuss in the electrostatic topics, we are just discuss the electric lines of forces, properties of electric lines of forces, the electric field. We are just discuss same. The magnetic lines of forces, they form a closed loop. The magnetic lines of forces, the magnetic lines of forces form a closed loop. But in the electric lines of forces they do not be happen this, they are form they don't form a closed loop. This is a closed loops. Consider we are take the vertical of this bar magnets, they are form a closed loop of the magnetic lines of forces. But in the electric lines of forces, but the electric lines of forces not done it, but electric line of forces not done it or have make a closed loop. Electric lines of forces not done it or make open loop. We are just discuss about the comparison between the electric field and magnetic field, electric lines of forces or magnetic lines of forces, for the better understanding of both electric and magnetic field. The directions of the net magnetic field B bar, the direction of of net magnetic field, we are shown the magnetic field as a letter capital B bar. This is the vector quantity. We are discussed the scalar and vector in the mathematical method when we are use the whiteboard. The directions of the magnetic field B, or the directions of the net magnetic field B at a point, or at any point, is given by consider a point. This is the electric lines of forces. I will be consider this point. Then the directions of the net magnetic field at this point is given by the tangent of magnetic lines of forces, and it is the tangent of magnetic lines of forces in the directions of magnetic field, in the directions of magnetic lines of forces, or in the directions of magnetic lines of forces. They gives the tangent is the tangent of, given by tangent of, gives the tangent of the magnetic line of forces, the tangent of magnetic line of forces and at a point they give the directions of lines of forces. Then the tangent of the forces at that point, they give the directions of the line of forces. At that point they also give the directions of lines of forces. Then the next property number 3, a number of lines of forces crossing per unit area is gives the magnetic field. The number of magnetic line of forces crossing per unit area is decide the magnitude of magnitude is one of only numerical value, and we are just discussed the net directions of the net magnetic field here, and we are discussed the magnitude of magnetic field, that is B bar. The number of magnetic lines of forces crossing per unit area is gives the magnitude of magnetic field. Then the magnetic line of forces do not intercept. This is the last properties. The magnetic line of forces do not intercept like this, do not intersect to each other. Do not intersect to each other. Then the density of the lines of forces is gives the magnetic field. Density of the lines of forces to gives the magnetic field. The number of lines of forces is called the magnetic flux. The number of lines of forces, there are 5 number of lines of forces here, then the magnetic flux at that point is 5. I will just discuss the unit of magnetic flux, but I will be revise the properties of magnetic lines of forces. The magnetic lines of forces form a closed loop. In the electric field, electric lines of forces, they do not done it. They are makes a closed loop like this. This loop will be closed of the electric lines of forces. The directions of the net magnetic field, that is B bar, at any point is given by the tangent of the line of forces, and they gives the magnetic lines of forces at that point in the directions of the line of forces. This is all about the second properties of. And third property, the number of magnetic lines of forces crossing per unit area is decide the magnitude of magnetic field. The number of magnetic lines of forces per unit area is decide the magnitude of magnetic field. Then fourth and last property of the magnetic lines of forces, the magnetic lines of forces will be do not cross, intercept to each other or cross to each other. Let's start to discussion some another factors. The factors, the number of electric lines of forces is called electric flux, and the number of magnetic lines of forces is called magnetic flux. We are revise the both topics, electrostatics and magnetism will be fill in this lectures. ठीक आहे, आपण इलेक्ट्रोस्टॅटिक आणि मॅग्नेटिझम हे दोन्ही लेक्चर रिवाइज करत आहे किंवा कंपॅरिझन करत आहे असं आपल्याला फील येत आहे, कारण की आपण इलेक्ट्रिक फील्ड आणि मॅग्नेटिक फील्ड बघत आहे, इलेक्ट्रिक लाईन्स ऑफ फोर्सेस बघत आहे, त्याचबरोबर मॅग्नेटिक लाईन्स ऑफ फोर्सेस देखील आपण या ठिकाणी बघत आहे. देन डेन्सिटी ऑफ द लाईन्स ऑफ फोर्सेस और मॅग्नेटिक लाईन्स ऑफ फोर्सेस डिटरमाइन द मॅग्नेटिक फील्ड. Okay, the density will be say here, then I will be write the density of magnetic line of forces. I will be write here MLF, magnetic line of forces, is determine magnetic field, that is B bar. This is the magnetic field. ज्या ठिकाणी यांची डेन्सिटी जास्त असते त्या ठिकाणी मॅग्नेटिक फील्ड जास्त असते. म्हणजे जी काय मॅग्नेटिक लाईन्स ऑफ फोर्सेस जर दाट असतील तर त्या पॉइंटला मॅग्नेटिक फील्ड जी काय आहे मॅक्झिमम असणार आहे. इट इज डिटरमाइन द मॅग्नेटिक फील्ड. देन द नंबर ऑफ लाइन्स of or number of magnetic lines of forces is called magnetic flux. The number of magnetic line of forces, that is MLF, magnetic line of forces is called magnetic flux. Magnetic flux, we are denoted magnetic flux is a phi, one of the Greek letters. The number of lines of forces, this is the 4 and this is the 4 is equal to, that is phi equal to 4. This is the number of lines of forces, the number of magnetic lines of forces is called magnetic flux. Then the SI unit of magnetic flux is, SI unit of phi is Weber, that is WB. This is the SI units of the magnetic flux. Then the magnetic field is the magnetic flux, the number of magnetic lines of forces per unit area. The number of magnetic lines of forces is the magnetic flux. This is the magnetic flux. and per unit area is decide the magnetic field. Consider the area A. This is the area A, and the all number of lines of forces is gives the electric magnetic flux and area A. Then I will be write the equation for magnetic field. Then magnetic field is equal to magnetic flux, that is the number of magnetic line of forces per unit area. Area is a it will be right here. Then the magnetic field B bar is equal to magnetic flux phi divided by area A. Then now let's start to calculate, or let's start to find the SI units of the magnetic field. Then the magnetic field, the SI unit of magnetic field is, it is the ratio. By using the formula we can calculate the SI unit of magnetic field. Then the SI units of the magnetic flux is Weber, that is a WB, and the SI units of area is a meter square. Then the SI unit of magnetic field is, SI unit of B is Weber per meter square, and this is also called as Tesla. This is also called as Tesla. We are denoted by here, that is smallest letter, that is Tesla. Is one of the famous scientists, the Nicholas Tesla. Then 1 Tesla is equal to, we are right conversion here, 1 Tesla is equal to 10 raised to 4 Gauss. 1 Tesla is equal to 10 raised to 4 Gauss. This is the conversion factor between the Tesla and Gauss. These are the unit of magnetic field. Well, let's just revise what are we study in these lectures. We are studying what are the magnetic lines of forces. The magnetic lines of forces start or originate from the North Pole and end to the South Pole. And we are just discuss some property about the magnetic lines of forces. The magnetic lines of forces are form a closed loop, but in the electric lines of forces they form a closed loop, but electric lines of forces they do not make it. Then the directions of the magnetic field at any particular point, the directions of the magnetic field at any particular point, then it is given by the tangent to, it is given by the tangent to the magnetic lines of forces. It is a tangent to the magnetic lines of forces at that directions, in the directions of line, in at that of that directions at that point, in the directions of electric lines of forces, in the directions of electric line of forces. This is gives the directions of the magnetic field. Then we are just discussed the directions of the magnetic field, and in here the number of magnetic lines of forces to crossing per unit area, it is decide the magnetic, this is the magnitude of, they decide the magnitude of the magnetic field. Then the magnetic line of forces do not be intercept to each other. These are all about some properties of the magnetic line of forces. Now we are just discuss the density of the magnetic lines of forces is determine the magnetic field. The number of magnetic line of forces is called as magnetic field. Number of lines of forces is called as magnetic field. Then magnetic flux. Then the SI unit of magnetic flux is a Weber. Then we are just find the magnetic field. Magnetic field is the magnetic lines of forces per unit area. Magnetic lines of forces is gives a magnetic flux per unit area. This is Weber per meter square, or the unit of the magnetic field. Then I will be give one of the best. Tesla is the one of the SI units of the magnetic field, then 1 Tesla is equal to 10 raised to 4 Gauss, or 1 Tesla is equal to 10,000. 10K is a 10,000 Gauss. This is the all about the magnetic lines of forces, properties of magnetic lines of forces and magnetic field.